doing is reviewing very quickly complementary, supplementary angles. I had just a couple of questions about those. Once we go through, do complementary, supplementary, again, a quick review, we're going to finish up with adjacent angles and vertical angles. So if you would, go to page 9. I didn't have a lot of questions here. The questions come from, well, how do I do this when I have variables? Okay, so what I'm going to do is I'm going to do this question, and I'm going to let y'all do the second question. So again, my thought process, if I know angles are complementary or supplementary, I know either angle plus angle is equal to 180, or angle plus angle equals 90. Now 180 is a straight line, 90 is a right angle. Well, the way I think about it again is I know two angles add up to either be a straight line or a right angle. What shape is made if you take the common ray out? So in this case, I have a line, which means angle 1 plus angle 2 equals 180. So I don't need this, and now I don't even need to know or remember my supplementary and complementary. For this particular problem, for the second one, you'll have to. Again, supplementary, complementary. But anyways, so I have angle 1 plus angle 2 equals 180 degrees. Now most of you may think, well, yeah, Mr. Harrell, I got this, but, well, is angle 1 plus angle 2 3, and then 3 is not equal to 180, so therefore it's no answer. No, we have to work on plugging in, and they actually tell you in like the beginning of the problem what measurement of angle 1 is. So for angle 1, I'm going to replace angle 1 with 2x plus 4. And I'm going to add that plus angle 2, which was 6x plus 20. And again, this is equal to 180 degrees. Again, you've done all of the hard work now. Make this a system. Or when we're solving for variables, make it a system. Type what I see on the left side of the equals and its own y equals. What's on the right side of the equal sign, put it in its own y equals. So that's exactly what I'm going to do. I'm going to go to Desmos. I'm going to type it in. 2x plus 4 plus 6x plus 20. And now again, I'm here, and I left off y equals. I apologize about that. But now I have 180. If I just type 180, I don't get anything. That's why it's so important to do y equals. Now again, when you solve a system, you just zoom out until you can see both graphs. And then, again, I like to zoom in to where I can very clearly see where they intersect at. If you click on a function you already have pulled up, Desmos essentially knows what the problem is asking. Alright? And again, we're solving for x. Again, the answer to a system is always x unless otherwise asked. Okay, so this particular time my x value is 19.5. So my answer, x equals 19.5. Now be careful, some questions ask you what's the angle measure. In that case, you could just go through here and you could plug that value in. Okay? So, for the next one, first thing, as a result of the problem, are the angles going to make a straight line or a right angle? They're going to make a straight line because I see supplementary. Alright, and again, when you see a straight line, what's its angle measure? It is 180 degrees. Therefore, this particular time, angle 3 plus angle 4 needs to equal 180 degrees. Now, we're going to work on solving for x. Okay. Process for solving for x. I have angle 3. You're going to replace angle 3 with what it tells you angle 3 is. So 12x minus 15 plus angle 4. Well, where's angle 4? There it is. 3x plus 45. I know all of that is equal to 180 degrees. Again, I have a system. You are able to do this because the state of North Carolina knows you know how to do this from Math 1. So this is a way of navigating around it. Take this system, I start over, I close off of everything. Again, whenever I start a new problem, I hit home and I zoom out to my normal view. And again, y equals 12x minus 15 plus 3x plus 45. I get to my equal sign, I stop, and I start a new y equals 180. Again, now I zoom out until I can see where my graphs intersect. When they do, I kind of put it in the middle. You can drag Desmos around, and then I zoom in and zoom in. And because it's a system, I want the x value where they intersect at, which is 10. Again, in the previous problem I told you that sometimes they may ask you to find the actual angle measure. If that was the case here, well, if I know x is equal to 10, I can plug in 10. So just I could do f of 10, and I rename my y equals f of x. Okay, and I get 180. Right, all of this needs to add up or simplify to 180, and it does. I'm not going to worry about the last one. Try this on your own. If you have questions, email me. Alright. Going to page 11, so starting the new stuff. Again, this should be pretty fun, especially because it's very visual. I'm going to tell you to go with your gut with vertical angles. What do I mean by that? Before I even get into the notes, nobody in their right mind would say that this angle and this angle look the same. Okay, so they're not the same. This angle and this angle, well, yeah, they kind of look the same. This angle and this angle, they kind of look the same. If they kind of look the same in vertical angles, set them equal to each other. Okay, now formalize the definition of vertical angles. They are across from each other. Okay, this and this are vertical. They are across when two straight lines. Again, a line is straight by definition, but I just throw that in there. Okay, and they share a common point. This particular point right here, we touched on it yesterday. I circled it. It is a vertex. Okay. Now, again, great thing about vertical angles, there's always one equation. They're always equal to each other. So angle GEH, so this angle is congruent to what other angle? Okay, so where else do I see a 46 at? I see a 46 here. So I kind of trap my values, and now how can I list the letters that are attached here to here? Well, I'll go FEI, so angle FEI, or I could say angle IEF. What you notice here is The order doesn't matter as long as your vertex doesn't change its place. So, what angle or angles is congruent to angle IEH? Angle FEG. Okay, or angle GEF, because IEH was 134. Where else do I see 134? Oh, here. Okay. So now I want y'all to do this. What's the measure of angle X? Again, so what's this angle measure right here? It winds up being 133 degrees. Now, if this is 133, what does these remaining two angles have to be? I teach this a couple of different ways. I tell everybody to hide or cover up like all of the extra stuff. So if I cover this up, right, this is what we were looking at yesterday, and then I cover up their common ray, I'm left with a straight line. So this piggybacks back to supplementary angles. Well, if one angle is 133, so like I'm going to put a variable here, y, so 133 plus y equals 180, find y. Okay, y turns out to be 47 degrees. Okay. Solve for x and then find the value of each angle containing x as well as the value of the other missing angles. Alright, so this one we have a bunch of stuff to do. So I want to solve for x. Again, angles are across from each other and not beside. Angles that are beside each other will share a ray. Angles that are across only share a point, with that point being a vertex. Okay, so I'm going to set these two equal to each other. X plus 16 equals 4x minus 5. Again, once I get here, Desmos does the rest. Y equals. Okay, so I start a new problem. I close out of everything. I hit home before I even type a new equation. Y equals x plus 16. Y equals 4x minus 5. Zoom out until you can see where they intersect. They intersect at 7. So x is going to be 7. Okay, so I solve for x. Now find the value of each angle containing x. So evaluate this, evaluate this. When you evaluate, all you do is plug in. Okay, so I can do, or I could call this f of 7. And now again, I could go f of x equals, and f of x equals, f of x equals 23, and then maybe I would have to call this a new function, g of x. Then I would do g of 7. The reason it didn't like it right there is because I can't have two functions that are the same name. But again, f of 7, g of 7, they're both 23. Okay. So this is 23, this is 23 degrees. Now, it also, these two missing angles here. Again, what do I know about these angles? They're both the same, and they're also complementary or supplementary to 23. They're going to be supplementary. Again, if I hide everything that's extra or that's new, I get rid of the common ray, it turns into a line. So, what's the supplement to 123? It is 157 degrees, 157 degrees. If this doesn't make sense, email me and I'll show you a different way. But moving right on to adjacent angles. So adjacent simply means beside. Okay, when two lines intersect one another, again, they share a common ray and a vertex. They, however, do not overlap. So this ABCD is going to be a visual. Angle 1 and angle 2. What do they have in common? So angle 1 is made up of this. Angle 2 is made up of this. The only thing they both have in common is this point. Okay? This point being the vertex, so they share the vertex. However, they don't share a ray. Okay? So I will say no common ray. Okay? Going on to B. In angle B, you have to really pay attention to these arcs right here. So that tells me one angle is this. So angle 2 is this. And angle 1 is the entire right angle. Because if you look at it, how it arcs, it touches from here to here. Okay. So angle 1 is the big right angle. It has this vertex. Angle 2 is the smaller one. It has this vertex. They share this ray right here. However, angle 1 overlaps angle 2. So B is wrong because they overlap. What about C? In C, angle 1's vertex is here. Angles 2 vertex is here. That automatically lets me cross these off because they don't share a common vertex. So no common vertex. Angle D, again, run through the thought process. Angle 1 is here. At the bend or the point is where the vertex is. Now I go to angle 2. The point is here, the bend is here. So there goes my vertex. Angle 1 is made up of ray, ray. Angle 2 is made up of ray and ray. So this is adjacent angles. Alright. Now, there's this fancy postulate, and postulates just are like fancy math terms. I just like to use this stuff as common sense. Okay? Angle ABC plus angle DCB is congruent to what angle? The measurement of angle B plus the measurement of angle DCB is equal to what? All this postulate says, if you have two smaller angles, it has to be a bigger one. So, what do I mean by that? If you have two $5 bills, you add them up, it becomes $10. If you have $5, your friend has $20, y'all together have 25. Okay? So just put the pieces together. You can also be asked the question backwards. If you and a friend have $30 in combined, you have 12 of the 30. That means they must have 18 of the 30. So you could be given the two small ones, asked to find a big one. You could be given a small piece and a big piece, asked to find a remaining small piece. That's all we're doing. Angle ABC. So hard part here is knowing which angle is which measure. So angle ABC is 22, it's this small one, plus D, and actually this is a misprint, this should be DBC, is congruent to what angle? So again, small angle is congruent to this big angle, ABD. Now, the measurement of A, that's what M stands for, the measurement of ABC plus the measurement of, again, DBC is equal to what? So, the measurement of ABC is 22. I'm adding DBC, so D to B to C is this arc, plus 39 equals 61 degrees. Okay. And then again, if this was x and we pretend we didn't know it, x plus 39 equals 61. Again, it would be x plus 39 equals 61. From here, y equals to y equals, if we do our system, it would wind up being back to 22. So, this is kind of like your classwork assignment for today. Solve for x and the missing angles associated with x in the problems below. Okay, or this problem right here. So, if I tell you, or if I give you this picture and all of this information right here is associated with it, where can I go? What can I do? What's the stuff we learned today? Okay, we learned about adjacent angles, we learned about vertical angles, so that's going to be my starting point. Right, that's the one thing y'all have going for you when we do stuff lesson by lesson, unit by unit, is that you get to actually know, oh, it's got to be within these certain couple of things. So, vertical angles or adjacent angles, what is this a picture of? This is a picture of adjacent angles because this and this are beside each other, right? There's not two sets of straight, or there's not two straight lines. It's all rays. Also, they're beside each other, and they fit the definition for an adjacent angle. Again, remember, adjacent angles, two angles, angle 1, angle 2, they share a vertex. Their common vertex being B. Okay, B is the common vertex. Also, they share a common ray. Okay, and then ray BD is the common ray. Now, what else do I know? I know that A, B, C, so A, B, C, this whole big thing is 88 degrees. Now, it's up to you to take this to be able to solve for x. Again, so where's my variable? My variable is here. Well, if I know this, I'm trying to find this piece right here. Again, this goes back to that question or that situation I told you. You and your friend, well, it costs $88 to get into a concert for 2 tickets. Your friend has got 64. How much money are you going to be able to chip in, or how much did you chip in? So, 88 is equal, the big angle is equal to the two smaller angles added together. You get x plus 4 plus 64. Now, find what x is. Okay? So again, go to my system. Y equals 88. Y equals x plus 4 plus 64. Again, I start a new problem. Y equals 88. Y equals x plus 4 plus 64. And then again, I zoom out until I can see where they intersect. Kind of bring it in the center. Click on it. X is 20. What's the value of the missing angle? So what's this angle right here? Again, I can plug 20 in and get 24, or I can just say, oh, big angle was 88, smaller angle was 64. What plus 64 is 88? 24.